Hello and welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today we'll be talking again about a little bit more complex case. In fact, we already touched it. Because remember, we were solving, in the very end of previous video, we went to solve this equation, x squared equal 1. And we got to results and we compared the results plus minus 1, but I want to talk about this a little bit differently. So we talked about this function yx x squared, and this function is this graph, and this is parabola and branches up, and x is here and x is here, and we solve this equation by drawing another function. This is y equal 1, and this is y equal x squared, and then we say those are the same, so x squared equal 1 are the same, and here we come immediately with solution 1 minus 1, 1, there are two roots, 1 and minus 1, and we immediately got it through plus minus square root of 1, x equal plus minus 1, and this was it, right? Then I want to solve this a little bit differently, because we already started to solve it using quadratic equation. And to solve quadratic equation, we always have to do everything to one side. X squared minus 1 equals 0. And then it will become 1 x squared plus 0 minus 1 equal 1, and a is equal 1, b is equal 0, c equal minus 1, and this is canonic form of this equation. With the function we have more freedom, because remember I wrote yx equal x squared minus 1. But I could say this, x squared minus 1 is my function. Because this is how it is. If I have quadratic equation, this expression is the same, but this is function and this is equation. So, if I am about to solve this quadratic equation, the corresponding function should be this. So, let's draw it. We know how to draw already x squared. X squared is this parabola, I just don't want to repeat it, but it's minus 1. So I have to add here minus 1, so my parabola would go like this. So if I know already how to draw parabola x squared, then parabola where a is the same, b is 0, but c is not 0, it's here, it's minus 1. So I shift it down. If this is minus 1, I shift it down. If I would write to draw a parabola x squared plus 4, this function, then I have original parabola and I have to move it up, and it would be this parabola. Whatever it is, the most important part is that if b is equal 0, then my function, quadratic function, would be like this, plus c, because b is not written here, and it may be 5, 10, any combination. And quadratic equation would be this. So what I am discussing today is a case when b equals 0. And when this is given to you like this, you have to understand that this is the same parabola, and parabola is up. If this is, when for example a is equal 5, or a is equal 7, or a is equal 2.5. It always be like this. And the parabola is shifted up by this value. If this is 5, it's shifted 5. If this is minus 10, it's dropped down 10 points. But the idea is that this determines how parabola is positioned up or down. One other word about a. For example, if y equal minus 5x squared, so c is equal 0, c is equal 0 as well, like b is always equal 0 today, and a is equal minus 5. What changes? If this is minus 5, then the graph would be x equals 0, 0, but x equal 1, it would be minus 5. And minus 1, it would be still minus 5. So parabola will become this, because this would be x squared always positive, and minus 5 always negative. So this result will be always negative. And negative means parabola branches are directed down. So parabola is directed down. And this is automatically means that a is less than 0. Okay? So we have two very important things that we discussed today. And this is expansion of what we discussed yesterday. We have this: if a is greater less than 0, parabola is looking down, always looking down, x and y. If a is greater than 0, parabola is always looking up. And this is fundamental. This picture and this picture. As soon as a is positive, parabola is growing, because this number will be always very positive, no matter how big is b. After some very big excess, this would be all positive, and this would be the maximum contribution, and parabola will go up. If this would be negative, if you supply significantly big x, 1,000, 10,000, million, billion, this always would be bigger than this, and this would be the main contribution of those two numbers. And with a positive a, it would be positive. With negative, it would be negative. So that means that this is going down or going up. And finally, the c. If c is greater than 0, your parabola will move a little bit up. And it doesn't matter if this is a positive parabola or negative. The parabola, original parabola, may be this. But when we move it up, it would be this. So if c is greater than 0, we always move it up. And basically that's it. If c is less than 0, we move it down. Let's go with a couple more examples. So it would be, for example, yx equals 7x squared plus 3. Okay, we know for a fact that a7 is greater than 0, so this parabola will be directed up. Something like this. What we don't know is whether it will be this or this, but this is very simple, because 3 is greater than 0. So we start with very simple parabola without c, and then we move it up. If we move it up, this would be our final result. Final result for this function. Does this function crosses horizontal line? No, it does not. Accordingly, 7x squared plus 3 equals 0 has no solution. And obviously it does not, because no matter what x you take, this would be positive. And you take another positive, so it would be more than 3. This would be 3. So there is no solution for this. And this is kind of obvious, right? Now, if I take minus 3, it would be minus 3. This part would be the same. Parabola is up. So it may be this or this. But minus 3 is less than 0. So when we take here 7x squared minus 3, it would be like this. It would be minus 3. When x equals 0, only this will left. And so this would be the point, the apex of my parabola. And of course, it's possible then to solve this equation, minus 3 equals 0, because this would be positive, this would be negative, and they will cancel out. 7x squared equals 3, move it here, change the sign. X squared equals 3 over 7, move it here to denominator, and x becomes plus minus 7 over 3. You can do it with your calculator. It's put square root from 2.1, it would be roughly 1.45. I don't need a calculator. Okay, so this would be 145, and this would be minus 145, roughly. And this would be this parabola, up, moved down, right? Okay, let's draw another parabola. And this parabola would be, for example, minus 7 and minus 3. So we have a less than minus 7. That means if you take x big enough, 1,000, 10,000, it would be like big number, and this would be even bigger number. And more x you will take, so you're moving here or you're moving into negative direction, doesn't matter, but you take big x, this becomes very negative. Very negative means it would be something like this. Or it may go up. So what it will be here? Minus 3 and less than 0. So you will take some number and you have to drop it, minus 3. So when x equals 0, this is the apex. 0 minus 3, this would be minus 3. So this would be the graph. Parabola is directed down and it's moved below the axis. And let's try to solve the equation. Y over x equals 0. Minus 7x squared minus 3 equals 0. We're trying to solve this equation. And obviously we cannot, because this is always negative for 0 and this is a negative. So it's a negative number, but let's do it through the formulas if you don't believe me. Move here would be 3. Divided over 7 would be x squared equal minus 3, 7. And no matter how you take the square root of minus 3, 7, no one knows what it is. So no number multiplied by itself can be negative. So this is no solution here in this case. So the bottom line is, you of course can use this formula too. And I suggest you try for those examples that I just displayed. But for the time being, all I wanted to discuss here is the case when b equals 0. So a not equal 0, c not equal 0, and we have the parabola. A determines where things are going up or down, positive or negative. And c determines how high the apex is located. And if it is ax squared plus c, the apex is always, as we pointed out, when x equals 0. So the apex here. So it's always symmetrical. This, or it may be this, or it may be that, or it may be this. All those parabolas are symmetrical. The non-symmetrical case would be, and I will introduce this next time, when b is not equal to 0. But here it's all symmetrical, And our solution is plus minus the same number, remember? C over A, right? And that's about it today. So, next installation I will be talking when I will introduce B, because this will be a little bit more complicated, but the same idea. Anyway, subscribe, bell, like, question, problem. See you next time. Thank you.